Hello, statistics student. This video is for chapter 6.2 part 2. We continue with more examples on how to use the online normal calculator to find probability or find cutoff to solve some work problems. So the example 3 is given pulse rate of a woman is normally distributed with a mean of 74 bit per minute and standard deviation of 12.5 bit per minute. Find the pulse rate of the lowest 5% and the highest 5% of women. So maybe if you have the lowest 5% or highest 5%, there's some kind of condition, or that the doctor need to be aware of. So we would like to. I mean, we have been doing a lot of examples on greater than, less than. So let's do something that is in between or outside. So the total area is the pulse rate is, if it's lowest 5%, that means 5% of the pulse rate are higher than you, or 5% is lower than you. It's the two tail size, right? So we want to find these two cutoff. So we add the area together. 5% of 5% is 10%, that's 0.1. And so we would, because we are finding cutoff, we use the inverse normal calculator. Okay. So write down that the mean is 74, standard deviation is 12.5. Okay, so it is inverse, right? So it's 74 and then 12.5. We want the area of 0.1 because it's the outside, right? So it's outside. That's it. 53. If the pulse rate is 53.4 to 94.6, that would be it. Okay, so click outside, recalculate. 53.4 and 94.6. You use outside. The area is the total area, not one though. So add them together. And if you put 0.1, you cannot. So they assume that it is 0.5, 0.5 on 2. So this is only useful if you have two tail that is symmetrical. Next example is a circus farmer. I think it's citrus farmer. Grow mandarin oranges. I think it's a typo here. Citrus. Farmer grows mandarin oranges, finds that diameters of mandarin oranges harvested on his farm follow a normal distribution with a mean diameter of 5.85 and a standard deviation of 0.25 cm. So A part is to find the probability that a normally selected mandarin orange from his farm has a diameter larger than 6. So this is a find probability one, and we want to find whether it is greater than 6. So we know this is 5.85, which is the mean, and then 0.24 is the standard deviation, but we don't know where 6 is. Is it here or here? So let's find Z. C is, so because we know that we should have 2 tick mark, 3 tick mark, like that. 1, 2, 3, right? C would be 6 minus 5.85 over 0.24. So that is equal to 6 minus 5.85 divided by 0.24. It's 0.6 only. So it's really close to the middle, right? So this is like 0.6 tick mark. And greater, larger. So it'll be this area. So you expect this to be pretty close to 0.5, right? So enter those, and we want to use above. 5.85. No, we don't want inverse. We want normal distribution. 5.85, 0.24, and I want above of 6. We calculate 0.266, 0.24, 5.85, 6. Oh, okay. I thought it would be close to like 40%, but it's actually 0.266, 26.266. Greater than 6 is 0.266. Okay, B. Let's do the middle. Find the middle 20% diameter of mandarin oranges from his sound. Fine. Use the inverse normal, right? Because we want to do the middle. That means we want to do the cutoff. Middle 20%. So this is 5.85. So in the middle, and it is the whole thing's 20% middle, and we want this cutoff x1, x2. So we would use inverse normal because that's used to find, and we use in between because the between is 20.2, right? The between area is total 0.2, and then it is actually really small. 74, is it 74? No. Is another question. 5.85, 5.85, and then 0.24, I remember. And then you do recalculate. It's 5.789, right? So we do in between, yeah. 5.789, this number. And then the high number is 5.911, 11. So if you round it, it will be 5.8 to 5.9 is 20%. So the middle 20% had that diameter. One last one, which is quite useful in terms of like warranty of appliance or any merchandise that you buy. Certain merchandise has life, right? So you can use it forever, like watch, battery. I think pretty much everything has a life. Or TV. So and they're usually normally distributed because they're manufactured by factory process, and usually that involve multiple steps, and so they would tend to have a life that is normally distributed. Sometimes, if you're not lucky, you buy something called lemon, which is fail right away. So it's possible. Okay, it's a process. A TV has a life that is normally distributed with a mean of 6.5 years and a standard deviation of 2.3 years. If the company offer a warranty to replace any TV that fails within 2 years, I think when they say replace any TV within 2 years, that means they fail within 3 years. I mean, it doesn't work because it's supposed to be on average 6 years, but now it fails in 3 years. What percent of TV will need to be replaced? So that means find percentage, and these are the low number, right? So the middle is 6.5, and you have 3 here. What is 3 actually in terms of the z-score? 3 minus 6.5 divided by 2.3. So I wonder how many standard deviation is it away? 3 minus 6.5 divided by 2.3. Oh, it's negative 1.5. So it's just one and something tick mark. So there's quite a number of them, right? So it's a quite high percentage. So it's negative 1.52. So you know that it is around here, not all the way to the end to sketch that area. So I want percentage, so I would use the normal calculator. My mean is what? Forgot. 6.5 and 2.3. 6.5, 2.3. I want it to be below 3 years, so I want to know how much that company has to replace. 0.064, so 0.064, that is 6.4%. So all the TVs, 6.4 of all the TV will have a life less than 3 years, and all these will be replaced by the company. So yeah, so this is how I think, like, you can put this into the cost. So when you mark up the price, or specify the price for the TV, these expenses will be calculated into the price so that it is all covered. Okay. And of course, you can buy additional warranty that will say, okay, if you fail within 4 years, we'll cover you. But then you have to pay more because there'll be more TV that would fail within like in longer year. Okay, so this can be used in case products are normally distributed. So this is all the application of normal distribution. That's end of 6.2.